This problem is about converting Roman numerals to integers. And so we will be given a number that is in Roman numeral representation, and we need to convert it into the integer form. If you look at the symbols, we have 7 different symbols and their corresponding values. And usually Roman numerals, they are written from largest to smallest, and though there are edge cases where we have a subtraction if there are specific numerals before the current numeral. So, for example, if I is placed before v or x, we subtract 1 from your x. If x is before L or C, we subtract 10, and then if C is before D or M, we subtract 100, which is the value of I, X, or C. And so I'll show you 2 solutions, and we will go from kind of brute forcing this to a more elegant solution as we identify some patterns here. So the first thing which is clear is that if the to handle the subtraction, we need to know what the current or the previous value is. So we need to know what the previous symbol is, and we will initialize that. And then we will obviously be iterating over every single character in the string, and we will be keeping some sort of current sum, and we will initialize that to 0. And to know what actually the value is of any particular character, we can completely represent this structure in a dictionary. So we can do symbol values, and this is a dictionary of string, which is the character symbol, and this corresponding value. And we can simply map this out to the mapping given to us. And then inside of our loop, we want to know what the value of the character is, and we can simply do a lookup on our dictionary for that particular character. Now, to handle the special cases, which is the subtraction, we are told that there's 6 exact cases, and so we can kind of store since the subtraction will change what value we need to add, we need to ideally store some other revised value, and we will initialize that to the character value. And so the intuition is that whatever character we're on, if we are subtracting it, then we want to reduce the revised value by the amount that we are actually subtracting. So we can handle these cases. So if char value, or if we can look at the previous symbol. So if previous symbol is equal to I and the char is equal to B, then we want to update our revised value to equal the char value minus 1 and then minus 1 again. So we could just hard code that to 3, and that would be cleaner actually. But I will write 3 here. And the reason why it is 3 is because note that if IV equals 4, which is what we are currently equating the string so far as, we already added 1 before that because there was I, and so we need to actually subtract 1 and then plus 4, which is what IV is, and so that's why it equals 3. So we are not doing 2 different steps here. We are subtracting and adding the revised value at the same time. So that's why we have 3, and the same logic applies if we are doing all of the other cases. So in here, it will be 8 as, again, x equals 9, and then minus 1 plus 10 is 8. And then we can just do the same thing for the other cases. So previous symbol equals x, and char equals L, realized value equals 30, if previous symbol equals x, and char equals C, then revised value will be equal to 80. And then lastly, the final two are C and char equals D, then revised value will equal 300, and if previous symbol equals C and char equals M, then revised value equals 800. Now, once we have the revised value, all we need to do is add that to the sum, and then we want to update what our previous symbol was. So previous symbol equals the current character. And then we can simply return the current sum. And this would be the brute force method. And so if we run this, it will pass the test cases, and this is a lot of boilerplate that we had to write, but now I will show a kind of way to optimize this. So as you see, we kind of hard-coded our special cases for subtraction, and as we've been doing these 6, if you notice, there is a pattern here. Every single time, so the first thing is every single special case is always subtracting subtracting when the previous symbol is a value that is less than the current symbol. So for example, we only subtract when the previous symbol is less than whatever symbol we're on. So I is always less than well, I is less than 5 and 10. 10 is less than 1500, and 100 is less than 500 or 1000. And this is true for any kind of combination, if you notice. And so we can apply the logic that if the previous symbol is less than the current symbol, then we can actually decrement the value and then add the updated value without having to kind of go through every single case. And so if you remove that, and we don't even need the revised value anymore, we can just deal directly with the char value, and we will handle subtraction by doing if the previous symbol, we will need to look up what the previous value is, which is simple values, previous symbol. So we will initialize previous value equals none, and if previous symbol, then we can look up in the dictionary, and then we can do an if previous value is less than the char value, then we want to do the current sum minus equals. So we want to reduce it in that step. So we're reducing it by not only what the value of the previous value is, but also we're doing that again because what our current value is, if you notice when we were writing out all of the steps, we actually not only needed to subtract the previous value, but then also take that away because current thing that we are adding is also reduced by the same amount. And so it's this actually previous value times 2. And that would do all of the reduction necessary such that we can re-add the original full value. So we're not actually changing what we're adding. We're actually now decrementing such that we can add the current value. And so just also in this loop, we need to do if previous value and previous value is less than char value. And then now if you run this, it should pass again, and it would be a lot more concise to write compared to having to hard code every single special case. And so that's all for this problem, and thank you for watching.